Assalamualaikum warahmatullahi taala wabarakatuh. Selamat pagi. Khabar semua selamat melalui tempoh akhir bulan puasa dan selamat pagi semua. Jadi pada hari ini kita akan masuk topik baru iaitu kaitan dengan fluid statics iaitu hydrostatics forces. Okay. Hydrostatic force on submerged surface. When a surface such as a dam, water gate, the wall of a liquid storage tank, or the whole of the ship is submerged in the fluid, forces develop on the surface due to the fluid pressure. The complete description of the resultant hydrostatic force acting on the submerged surface requires the determination of its magnitude, its points of application or its directions, and the lines of action of the force. For fluid arrest, we know that the pressure varies linearly with depth if the fluid is incompressible. The approaches in determining the hydrostatic force on horizontal, vertical, tilted, and curved surface are quite different due to hydrostatic fluid pressure distribution on that particular submerged surface. So this is the sample of the pressure distribution on horizontal plate, vertical, tilted or inclined, and curved surface. So the curved surface, we know that the is about the sample of a circle, and B and C is a structure with a dam. Hydrostatic force on horizontal submerged surface. So we can see the diagram here is about the horizontal surface, such as the bottom surface on a tank as shown in figure. The magnitude of the resultant force is simply given as shown below. Fr is equal to PA, so P is rho GH. So where P is the uniform pressure on the bottom and A is the area of the bottom surface. Since the pressure is constant and uniformly distributed over the surface, so the resultant force acts through the centroid of the area. So this is an example of the questions about the rigid shape gate OAB is 3m wide and hing at 0 and rest against a rigid support at B. Find the hydrostatic force acting on the plate AB. So we see that AB is a plate. So find the find the resistant force is equal to PA. So P is rho GH. So is rho 1000 times 9.81 times 7. So time area. So we get 412 kilonewton acting through the centroid of the plate AB. So hydrostatic force on the vertical submerged surface. For the vertical surface, the magnitude of the resistant force is given by Fr as gamma Hc times A. So gamma is rho G. HCA, so Hc is a vertical distance from the surface on the centroid of the area. Besides the magnitude of resistant force, the location where this Fr is acting on also has to be determined. This point or locations is called as a center of pressure. The location of CP normally is described in terms of vertical distance, HR, or inclined distance, YR, from the free surface HRY. So this is a sample of the question, second sample of the question. The rigid L-shaped gate OAB is seen as 0 and rests against the rigid shape support at B. What's minimum horizontal force P is required to hold the gate closed if its width is 3 meter. Nail the width of the gate and the friction and the hinge. The back of the gate is exposed to the atmosphere. So this is the step of calculation for FR OB. Acting on the plate AB has been calculated, which is equal to 412 kilonewton. For plate OA, so OA FR is equal PC times A, so rho GH and CA, so 1900 1000 times 9.81 times 5 times 12. So get the amount of FR 588.6 kilonewton. For HR, So HR is a formula 3, okay, 3, okay, plus 2 over 3 H is equal to 3 plus 2 over 3 times X times H. So we get the here. Refer to the free body diagram for equilibrium. Hence M is equal to 0. So FR OA. So we have to get the number of minus 3 plus FR times 1 is equal to P4. So P get to know about the answer. The third questions is hydrostatic force on the vertical planes. An open tank has a vertical rotation on one side contains gasoline with the density to 700 kilogram per meter cube at a depth of 4 meter as shown in the figure. So rectangular blade that is 4 meter high and 2 meter wide and height at one end is located in the partition. Water is slowly add on the empty side of the tank. So at what depth edge will be start to open. The next question is the pressure tank contains oil G 0.9 and has a square 2.6, 0.6 meter by 0.6 meter plate to inside. It is illustrated in figure. So when the pressure gauge on the top of the tank with 50 kilopascal, so at the magnitude and location of the resultant force on the attached plate. The outside of the tank is at atmospheric pressure. So here now is the step how to do it, hydrostatic force on the inclined plane. The 4 meter diameter circular gate is located in the inclined gate of the larger receiver containing plate. The gate is mounted on the shaft along its horizontal diameter. For the weight for the water depth on 10 meter above the shaft, determine the magnitude and equation of the resultant force exerted on the gate by the water, and the momentum that will be applied to the shaft to open the gate. Now we go to the next slide, hydrostatic force on submerged surface. For submerged surface, determination of the resultant force typically requires the integration of the pressure force that can change along the curved surface. Okay. However, the easiest way to determine the FR acting on the curved surface by separating it into the horizontal and vertical component, FH and FV. Hydrostatic force on the submerged curved surface. This is done by considering the free body diagram of the fluid volume enclosed by the curved surface of interest and the horizontal and vertical projection of the surface as shown in below. You can see that in the free body diagram, there's two axes, one axis and an axis. So we have to concentrate on this. We have to concentrate on the vector of the V and Y, Vy and Vyx. So you get the resultant force, angle of the resultant force. This is the step summary of the procedure for computing the hydrostatic force on submerged curved surface. Number 1 is isolate the value of fluid above under the curved surface. Number 2, sketch the fluid diagram of the fluid flow, the fluid volume, and show the force involved. Discover the direction, the correct direction in allocation. Compute the fx rho g h2 in particle. Define first the h2 and first the h2 and vertical projection surface area. A vertical for fy. Compute f gamma rho g h. A horizontal and define the first the h1 and horizontal projection surface area. A horizontal for f. Compute omega w is equal to gv. Refer the first to volume, first volume. CB and FF. calculate the resultant force Fr from Fr equals square root of F square plus Fy V square. Is the direction of and is direction from theta is equal to tangent minus 1 Fy Fb by minus F1. Show the resultant force. Show the resultant force acting on the curved surface in the shows a direction that this line of action goes through the center of curvature of the surface. Sketch the body diagram show about sketch the free body diagram and show a soft volume using summation of mu is equal to 0 is equal. That's all for now. Thank you. Okay, Assalamualaikum. Kehadiran tadi boleh rekodkan di sini untuk pemerhatian semua. Jadi saya harap semua dapat ambil perhatian untuk kehadiran rekod di sini.